So hello guys, welcome to my video tutorial where today we're going to talk about three topics: infinite series, matrices, and determinants. Today we're going to answer three questions, one per topic. I hope you enjoy this video and I hope you learn something from it. Hello again everyone. Now let us proceed to answer question number 1 for infinite series. Question number 1. Find the first 5 terms and the n plus first term of the series whose nth term is 3n over 2n plus 1 squared. So, since the given nth term to us by the question is 3n over 2n plus 1 squared, we now let n equal to 1. That gives us 3 times 1 over 2 times 1 plus 1 squared, which is then 3 over 9, and simplified 1 over 3. Now we let n equal to 2. That gives us 3 times 2 over 2 times 2 plus 1 squared, equal to 6 over 25. Moving on to n equal 3, which gives us 3 times 3 over 2 times 3 plus 1 squared, which is equals to 9 over 49. For n equals to 4, we get 3 times 4 over 2 times 4 plus 1 squared, which is equals to 12 over 81, or in simplified form, 4 over 27. For the fifth term, we now let n equal to 5, which then gives us 3 times 5 over 2 times 5 plus 1 squared, which is equals to 15 over 121. For the n plus first term, we now let n equal to n plus 1, which then gives us 3 times n plus 1 over 2 times n plus 1 plus 1 squared, which is equals to 3 times n plus 1 over 2n plus 3 squared. We then simplify to 3n plus 1 over 4n squared plus 12n plus 9. For the final answer, the question asks for the first 5 terms and the n plus first term of the series, which then gives us the first term of 1 over 3, the second term of 6 over 25, third term of 9 over 49, fourth term of 4 over 27, the fifth term 15 over 121, and the n plus first term is 3n plus 1 over 4n squared plus 12n plus 9. Now, if in any case you were asked to find for the infinite series, this is how you write the final answer. 1 over 3 plus 6 over 25 plus 9 over 49 plus 4 over 27 plus 15 over 121, and so on. Now, let us move on to matrices. For question number 2, we are now asked to answer the problem which is 3 times the product of transpose of matrix B and transpose of matrix A minus matrix A squared plus the transpose of the sum of the transpose of matrix A and 9i, the I referring to the identity matrix. Here are the matrices of A and B. To answer this problem, we must find first what the question asks, depending on the given matrices. Since the transpose of the matrices A and B are not given, we need to find it first. Then get the product of it to be then multiplied by 3. Getting the transpose for matrices is easy. You just have to remember that the rows become columns and the columns become rows, as you can see in this video. The columns of A will now become the rows of it and vice versa. That goes the same for matrix B. Now, let us multiply the matrices. Since the number of columns of matrix B is equal to the number of rows of matrix A, then the two matrices are conformable and BA is possible. To get the product of the two matrices, the rows of the transpose of B is multiplied to the columns of transpose of A, as seen below. As we simplify further, we now then get this result. Now, we get the product. 6, 5, 1, -3, -2, 2, 1, 12, and 20. We now then multiply it by 3, which gives us the result of 18, 15, 3, -9, -6, 6, 3, 36, and 60. Now let's move on to the next part of the question. Matrix A squared. To get matrix A squared, we have to multiply it by its own matrix, as seen in the screen. Again, we make use of the rows of the left matrix to be then multiplied to the columns of the right matrix, as shown in the screen. As we simplify further, we now get the answer to matrix A squared, which is equals to -3, -10, -10, 8, 6, -1, 25, 25, and 17. Now, on to the next part of the question. We are now asked to find the sum of the transpose of matrix A and the identity matrix times 9. Of course, we first multiply the identity matrix to 9, and then we can now proceed in adding the two matrices. Adding matrices is simple. Now, with the two matrices given, having the same order of rows and columns, the sum must have the same number of elements in the matrix as well. We start adding from the first row, first column of the two matrices, then first row, second column, first row, third column. We then continue doing it for the second row and the second element in the first column, and so on, as shown in the video. Now that we got the sum, let's now transpose it, giving us the result of 10, 0, -2, 3, 10, 1, 2, 5, and 13. Now, let us put all together the data we have collected. To make things simple, we will do it one at a time to avoid confusion as well. We first subtract the 3 times the product of the transpose of B and A and matrix A squared. The same method of addition is applied when subtracting matrices by first row, first column, and so on. Now that we got the difference of the two matrices, let's now proceed to the final part of the problem. Let us now get the sum to get the final answer. Adding both the last matrices needed for the problem, the final answer is 21, 25, 13, negative 17, negative 12, 8, negative 22, 11, and 56. For the final question of this video tutorial, we talk about determinants. As matrices grow larger and larger, finding the determinant would be a bit challenging. In our case, this question makes use of the cofactor expansion to get the final answer or the determinant easier. Let's move on. For question number 3, we are asked to evaluate D using cofactor expansion. To find the solution, we're going to expand about the third column. As you can see in this solution, 0 is not included because it will just cancel out and take time when we try to solve or write it while answering. To get determinants using cofactor expansion, you have to remember to make use of sign charts like this. As you can see, I have highlighted the elements per bracket to avoid confusion. These elements are obtained on the normal method on how we get determinants, just like this example now. We can also do it like this to again avoid confusion. Now, as we simplify the elements we got from earlier, we get this. D is equals to negative times negative 36 minus 0 minus 20 minus 20 plus 36 minus 0 minus negative 12 minus 12 minus 8 minus 8 plus 12 minus 12 minus 0 plus 10 minus 12 minus 0 plus 10 minus 18. Simplified further, D equals to negative times negative 40 minus negative 40 minus negative 10, which gives us the result of D is equals to 40 plus 40 plus 10. The final answer for our determinant is equals to 90. So that's it for this video tutorial. I hope you got something from this like I did. Thanks for watching. So thank you guys again for watching my simple yet I hope educational video. I hope you learned something or picked up something from it. And always remember that when you're given difficult questions, just don't overcomplicate things because it makes things harder. So yeah, I hope you enjoyed this, and thank you again. Stay safe. Bye.